my share. Here's a quick agenda. There's another piece of the agenda that I'm missing right now, but basically, I wanted to point out that there's a workshop coming up pretty soon. It's actually, the first one is on Saturday. Let me get the, oh, 1 second. Let me just add this to the, to show, yes, Amazon SageMaker models. Okay, we've got lots of good stuff here. So TensorFlow, we're going to do PyTorch, we're going to do MXNet samples. We're also going to show the deep fake challenge, detection challenge. This is by Facebook, FB, and AWS. And AWS and it's a Kaggle challenge. Okay, so this is roughly the agenda. Here's the link for the workshop coming up. Let me type it in here, upcoming workshop. The first one's already sold out. It's been sold out for actually quite a while. I think we have slots available in February and in March. So we'll be doing it once a year. This is a free workshop. We'll be covering lots of stuff. KubeFlow will actually be doing lots of EKS, which is Amazon Elastic Kubernetes service. It's about, I think it's estimated at about 7 hours. Still finalizing the agenda for that. It's some of the same from last year, but updated to use EKS and the latest KubeFlow and the like latest and greatest stuff. So check that out. Okay. And EKS plus KubeFlow, so that's what we'll be focusing on. There's the link for that. We're going to be talking about some SageMaker models. And yeah, so quick introduction. My name is Chris Fregley. So introduction, Chris Fregley. Currently working at Amazon Web Services, developer advocate for machine learning, for AI and machine learning. Based in SF, San Francisco. We also have on the line Ansha Barth. She is the same. Ansha, do you want to say hello?
Yes. Hi, everyone. So my name is Antje. I work basically in the same role as Chris as developer advocate at Amazon Web Services, also focusing on AI machine learning. And as he's just writing here, I'm based in Düsseldorf in Germany.
Okay, great. So Ansha and I have been working together pretty closely the last few months. We went to reInvent. I think the previous, so last month, Ansha gave a nice overview during this time slot. That video is out there. All videos are posted to youtube.pipeline.ai. All videos will be to slides are posted to HBS slides.pipeline.ai, or actually slideshare.pipeline.ai. Okay, so that's a little bit about us. That's a little bit about the upcoming workshop. That'll be Ansha and I doing that together and over about 7 hours. It's on Saturdays, so hopefully people can make it. The other thing I wanted to point out is this deepfake detection challenge. Now, one thing you could do, we have this repo. Let me put this repo in here. It's still in the works, so GitHub, so new GitHub repo called Data Science on AWS. And in there is actually, if you click on Deepfake Detection Challenge, this will get you to all the assets that we've created. So this is a Kaggle competition. You can get to the link here. From this, let me grab that. Deepfakes are those things when you're on Facebook or on, yes, I guess Instagram or doing whatever you do, and there's a video that doesn't seem quite right. Maybe it has some fake news. Maybe it has the president speaking, and it's dubbed over, and it just seems kind of strange. So if we click into the Deepfake Detection Challenge here, we'll see. You can join the competition by clicking here. It's a Facebook challenge. I believe it's $1 million for the winner, $1 million in total prizes down here. So Facebook is sponsoring this. We are also sponsoring by giving credits. You can contact and follow these links to get to the Amazon credits. And we've built, Antje and I built this deepfake detection challenge GitHub repo that's actually pinned in the forums of that challenge within Kaggle. And you can click in here and follow the examples. And if you want to try to do it in TensorFlow, PyTorch, MXNet, we're just showing basic ways to use SageMaker and to train in a distributed fashion. We're not actually solving this for you guys. That actually would violate our terms of the partnership. So just know that these examples are just kind of generic examples, but they do show how to use and train and use those credits, which is really nice. So I imagine quite a lot of people will probably use TensorFlow, Keras, and this shows you how to get started with that. The other thing to point out is, yeah, there's a nice blog post here that you can link to, and we have all the steps. So if you do have to create a new Amazon account, you can create it there. You can apply the credits there, create an S3 bucket to download the data sets, review the regions, choose the region that's supported by SageMaker, potentially get increases in your limits so that you can maximize those credits and train on fun GPUs, and then how to get a SageMaker notebook instance running and tie it to this GitHub repo. So all the steps are here for you. Feel free to follow that. And if you win, I would love to hear about it. Just let us know. Okay, so that's Deepfake Detection Challenge. While preparing for the Deepfake Detection Challenge, I decided to also create this kind of more generic repo called Amazon SageMaker Models. And it looks like a couple people even have been starring it and forking it. So this is common examples. So these three are actually very similar, MXNet, PyTorch, TensorFlow, to the ones that are in the Deepfake Detection Challenge repo. Shows you, the instance type. We are also factoring in here, we're adding in here this factorization machines, like algorithm, to do factorization machine-based recommendations, collaborative filtering. So this is using a very fun data set. This is the Amazon reviews. This is Amazon.com. This is the Amazon Prime Video. These are all the reviews since 1995, I believe. And this is a public data set. There's about 2 million Amazon customers in this data set. This is from a few years ago, 160,000 digital videos, for example. So you can go here, follow this, and we're actually doing some fun stuff where we're creating recommendations just like Netflix, just like Amazon.com, and using Amazon SageMaker and some of the built-in algorithms. So not only can you use TensorFlow, PyTorch, and MXNet, but you can use built-in algorithms by SageMaker. There's this one called Blazing Text that's actually based on fast text, which is based on word2vec, or is similar to like word2vec. And this is actually kind of a clever way to generate recommendations off of textual data. And so you can go through here. I won't have time to go through the details here, but if you follow this notebook, you can get this stuff running. Again, this is public data set. And at the end of the day, we're actually training a blazing text or fast text word2vec model, building in the, we're like creating the embeddings for each of the movies and then finding similar movies based on similar like textual recommendations. So kind of cool. Check that out. All right, I'm scrolling like crazy here. Let me go back to the agenda. All right, so let me drill into one of these actually. If I go, so this is actually very much the same as the deepfake challenge. So I'm just going to go in here, and here's the notebook. So this is using what's called SageMaker script mode. Now, SageMaker is very flexible, and some would say even too flexible. There's actually multiple dimensions to the Amazon SageMaker product, which is, and so like pretty much all of this is open source. All of the code that you need to create these jobs on the back end. So think of SageMaker as a managed training service or a managed model serving service. And so you can even Let me put a note in here just so I don't forget. You can even do Amazon SageMaker plus KubeFlow. So I'll show that here in a bit. There's something called the SageMaker KubeFlow operator, native Kubernetes integration for SageMaker and KubeFlow. Okay. So there's multiple modes. You could use kind of pre-baked SageMaker like TensorFlow containers and just put in your TensorFlow train.py, and that's typically called script mode. It's kind of a weird name, but think of it like you just provide the script and SageMaker takes care of the rest. That's the level that we're showing here. You can also actually create your own containers with completely different base containers, or like do whatever you want and push it into SageMaker, and SageMaker will run those containers. Just as long as you obey a particular style of just calling the train.py, and I think there's like some bash script hook. So yeah, this is all documented, but the more custom that you want to be, the more you're sort of on your own. But there is documentation, and you can submit basically any Docker container or a Docker image that you built into SageMaker, and it will run. This is actually kind of an in-between stage. This is where we're reusing the TensorFlow container because there already is a pre-baked TensorFlow 2.0, and for the GPUs, this has all of like the NVIDIA libraries and CUDA kernels installed, and it's CUDA 10.2. It's all the latest. And so all you have to do is actually just give it this is Keras, this is MNIST Keras TensorFlow 2.py file. You also give it a requirements txt because it's very likely that you probably have your own either internal libraries that you have built, and these dependencies are needed by the script, or you just want to pull in different versions of NumPy or Scikit or whatever. So this is this is how you invoke. So keep that on your like mental stack. Let me open up the other one here. I'll put this side by side in a sec. So this is the actual script. So when they talk about script mode, this is actually what they're talking about here. So let me put this over here. So I actually need to go into the source, go into the source directory. You'll see there's a requirements txt, which actually this one doesn't have any custom requirements. It's a pretty straightforward Keras TensorFlow model. So this is what you're used to looking at, which is, here's a model, here's my model compile, this is my Keras building it up, TensorFlow 2.0 using the Keras API. These should all look familiar, basically loading up NumPy arrays, the classic parse args, that's very common within Keras and TensorFlow, loading, creating the model, printing some things out. Now, this is one thing that's a little bit wonky. This is for when you're doing distributed TensorFlow. You really only want one of these nodes. There's always going to be args host 0 because no matter what, there will be at least one host. And if you have two hosts, you only want one single host to actually save the model out to S3. And I believe there's some, sort of utility functions here to sync to S3. And this is really for tensor board integration. So can try to show that a bit later, but just know that you can actually embed tensor board into your SageMaker notebooks and use all that. So I was actually really surprised when I saw that and couldn't believe that it actually worked, but it did. It was pretty slick. It opens up a port, it builds a proxy into that, so you could access it from the public internet if you'd like. Okay, so here's your script that you define. Here's the requirements txt, showed those before. And now we're actually going to take that script and we're going to point to it. So let me zoom in here on this. Entry point, I'm pointing to that Keras file in this directory. This will automatically pick up the requirements txt, by the way. We're giving it an output path to when it trains the model, where to put it. that's this. Of course, you got to deal with your IAM roles and follow the like least privilege, where you only give access to exactly what you need here. In this case, it'll likely be some S3 buckets. You need access. This particular role that you're specifying here should have access to write to that particular bucket and this particular prefix. You also need some quota for these SageMaker specific instances. So note that ML dot means it's a SageMaker instance. If you just provision a C52XL, it will not work. And those are actually separate instance types. They are fundamentally the same instance. It's just the way that the internal Amazon accounting and like capacity planning. So these are ML dot. So just know that you might actually have quota for a C52XL, but you might not have quota for an ML.C52XL. So just like create a support ticket, or off the deepfake challenge, there was a link to contact support and to get those limits increased. Here I'm specifying framework version is 2.0 because it's TensorFlow here, and this is just a simple import. I'm also telling it to turn on SageMaker metrics. This means push things into CloudWatch. Script mode equals true. I think this is actually deprecated. I don't think you have to specify this anymore. It'll just detect it, tell it which version of Python. And when you're doing distributed TensorFlow, you need to pass this in, which is, are we using parameter server mode? And so parameter server is a separate cluster, if you will. Actually, the way it's implemented is each parameter server actually runs on each of the instances up here. That's just that is an implementation detail that the SageMaker team has chosen. But just know that the parameter server is what lets you do distributed training. You can do distributed training without like parameter server mode actually with newer TensorFlow 2.0. In that case, you're using the like all reduce strategy, distributed strategy. Probably too many details for this discussion, but just know that. And here I only have train instance count as 1, just so that when people get started, they don't like use up too much quota. But all you would do is add 2 up here, 3 up here, 10 up here, whatever you want. Of course, good Amazon practice using Amazon Web Services, always set the key value pairs like that. And note that when you turn on the SageMaker metrics is true, you'll actually start to see these logs coming out. And this is a tiny bit wonky, I have to admit. When I saw this, I was a little bit shocked that it was this wonky, but this is how it works. Basically, we're scraping the container logs during training and performing regexes, and whenever we see in the logs something, so this is a physical log line being spit out by the TensorFlow training job. And SageMaker is capturing those logs and putting those values into these metrics, okay? Now, these change sometimes from like release to release. I was debugging something recently, past couple of weeks, where we bumped up to, I think, PyTorch 1.3 or 1.2, and all the examples we saw for PyTorch, all these regexes were bad. And so I wasn't seeing any metrics in CloudWatch, and I want metrics in CloudWatch because I want to do experiment tracking, and when, and yes, I can compare multiple runs of each training job. Okay, one thing to note is you can call fit. Now this is from within a notebook. You could also call this from a KubeFlow pipeline, which I'll talk about in a sec. You could call it from a step function, which is sort of the like Airflow for like Amazon Web Services. They're called step functions. So there's lots of ways to actually call this fit. If you're doing it from a notebook, I would highly recommend that you say wait equals false. This means put it in an async mode. You would call get the latest job name. So that's going to tell you the job name of that run. And then from there, you could do, between this cell and this cell down here, you could do a bunch of stuff. And then when you're ready to actually reattach to that live running training job, you can reattach, and then this will start spitting out the logs. Once training's done, we can verify that the data has gotten there and that the model has been built. From that point, we could actually, just kind of inspect the model. It's going to automatically tar it up into model.tar.gz. Of course, TensorFlow and Keras, well, in this case, we're actually using the TensorFlow saved model format. And you can also use the H5 format, of course, with Keras. We then load it up, and we can start to inspect that model and actually do live predictions here right in the notebook. Now, the other option, this is just for kind of ad hoc. Let's make sure that the model appears, if we pass in an image, a digit, right, like between 0 and 9, a handwritten digit, that it's somewhat close, and it seems to be correct. And then also, we could then take that model and deploy it as a REST endpoint. And so these are the steps to do that. You can call deploy, tell it the number of instances, give it the SageMaker instance type that you want. So typically, you would want to train, like most likely, with the P2s or the P3s or the Gs. Those are the GPU instances. But when you go to actually deploy the model, you can potentially step down to a CPU-based instance and still get pretty good performance. And here's how we're calling the endpoint. Okay, and here we're calling predict. This is actually making a REST call beneath the covers and pulling back that prediction. So once this works the same way with PyTorch and with MXNet. Also, you could do Scikit-Learn. You can basically do anything as long as there's a I think it's /invoke or /invocations. If there's a REST endpoint in there, then SageMaker can serve it. Okay, so let me go back to the agenda here. I'll spare you the details of the PyTorch and the MXNet. Just know that it looks exactly the same. Actually, I'll show you guys the PyTorch one real quick, just to prove. It looks exactly the same as the TensorFlow, except for one small, let's see, import. And so when we train, there's that MNS PyTorch.py file, which will have PyTorch code in it, similar to the TensorFlow Keras code. All that changes is this, from SageMaker.pytorch, import PyTorch, boom, boom, put that right there, and then everything else is the same. Specifying source directory, there's requirements txt in there, passing some hyperparameters. I don't know if I mentioned that on the TensorFlow one. Tell it which version of PyTorch, so 131. These notes, these are a different regex pattern. So I actually looked at the logs, which is very easy through the notebook when you do the attach, or when you run with weights equals true, you'll actually see the logs right in the notebook. Okay, so you can kind of scrape it out and figure out the regex. Again, you have to do this one time, I guess, and then double check it whenever you upgrade PyTorch versions. And these metrics start showing up in CloudWatch, and you can start building dashboards to share with your data scientists as to how the models are doing during training. Okay, all the rest is the same. We're attaching, we're looking at the model, or then we're testing it inside the notebook, and then creating the SageMaker endpoint. Again, it's doing the same thing. It's called .deploy, how many instances, what type of instance. And then beneath the covers, you can look into the details. There's a whole host of containers here. So this is the SageMaker PyTorch container. There's also a TensorFlow container. All of this stuff, if you're interested, all of this stuff is open source. So let me see, where was that container? I actually didn't know this myself. I had assumed that these were not public, but they very much are. So PyTorch container, those of you that are interested will want, the first thing you're going to ask is, where's the Docker file? I'm going to show that to you. There's a CPU, and for giggles, let's pull up the GPU one, and you'll see something very similar. So they're actually basing this off the NVIDIA base image, because that does take care of quite a bit of the pain of the GPU drivers. And then, so you can actually copy and paste this and use this as your base or your Docker file, and then tweak, yes, anything in here that you want. If you want to try a different version of MPI, you want to try Python 3.8. I wouldn't recommend it unless you absolutely know what you're doing. These Docker images get really, really hairy very quickly, especially with versions of CUDA. So it looks like there's only on 10.1. But yeah, just know that there is full transparency. And these are the actual, when someone says, I trained a model on SageMaker, it is literally using that Docker container. Now let's find the TensorFlow container, SageMaker. I've had to go into this many times to figure out what's going on and work backwards from here. So where's 2.0? I thought 2.0 was in here. Anyway, let's crack over 1.5. And we can see, and you can go in here and look for TensorFlow, or if you're looking for NumPy, and actually see the exact versions that are being used, Keras 231. Okay, it's got all the licensing stuff needed to get to the GPUs and those base images. All right, let me get back on track here. A couple people I think are interested, I know are interested in SageMaker Kubernetes operator. And this actually came out during reInvent. It's a cool blog post here if you're into this kind of thing. The business use case here is you have a existing Kubernetes cluster, and you're either building KubeFlow pipelines or you've built your own pipelines, maybe you have Airflow, and you are either training models and finding yourself, kind of stuck in like a lot of Kubernetes operations land, when all you really want to do is train a model and then get the results back and then continue on with your pipeline. So AWS recently released the SageMaker operator for Kubernetes. Now the term operator in Kubernetes land is kind of a custom like data type, or like a UDF, if you will, like user-defined function. That's a very, very gross like generalization, but for those of you familiar with like database technology there and like APIs, you can introduce your own types or your own functions, and think of this as a way to tell Kubernetes how to talk to SageMaker managed service and do it natively. So with this, you could actually do kubectl, get SageMaker jobs. You could look at the logs. I'm trying to see if they have an example here. It's fully built, or it's fully compatible with all the Amazon security. So CRD is called custom resource definition. That's actually the new name for operators. That's kind of the more modern way. So get CRD, and so here we're actually telling, so there's code that lives inside of these custom resource definitions that knows how to talk to the Amazon Web Service API to create these training jobs, to deploy models, to run hyperparameter tunings, to do batch transformations. And so that's kind of nice. That then is a pathway to actually integrate KubeFlow pipelines with SageMaker, which seems kind of weird. But if you've ever tried to build your own KubeFlow pipeline beyond the simple samples, you like quickly realize that you're creating Docker images for everything, and you're right, like having to manage all these Docker files and like different. So here you could simplify all the model training and push it into SageMaker and just treat SageMaker like a black box or a white box, gray box, and call into it and then get the results, and everything is all in one place. And Saturday we'll actually dive more into this and have an example. And let's see, you can create your own. So you can either use the Amazon deep learning containers like I was showing before, or you can introduce your own. Here's an example of the YAML, and for those of you interested in this level of detail. So this blog post I pasted in the chat. You can specify the Docker image, either the Amazon one or your own. You could tell it the input mode, either file, which is or pipe. You almost always want to use pipe mode. Because when you're training, you want to try to if your data is in S3, you want to reuse S3's distributed capabilities and have all those nodes that are participating in the training job to pull from S3 in parallel. If you do file mode, all of the data gets copied to all of the worker nodes, and then training starts. And this could take upwards of an hour or days, even depending on file size. So always, 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 if you can, use pipe mode, P-I-P-E. You can Google that and find it in the docs. Here we're specifying instance count. This is all very similar to what we're doing through the SageMaker API. And of course, beneath the covers, this Kubernetes operator has been built with the SageMaker API. It's just, this is doing it for us with configuration through like Kubernetes. Okay, so we'll talk more about this later, but yeah, check this out. Keep an eye on Aditya. I got to meet him at reInvent, and super nice guy. Okay, so we got to that. One thing Antya and I have been doing, so we've got about 30 minutes left. I don't think we need that much time, but I do want to go through something that we discovered actually the last couple weeks since reInvent, which is called processing jobs. So if I go into, see if I got so many tabs open here. Okay. One sec here, I'm going to go into the SageMaker console. If you are fresh to SageMaker, you might be a bit overwhelmed here. SageMaker is kind of the overall term for the Amazon AI. Well, specifically more the machine learning side of things versus the AI side of things. So this is a tiny bit off topic here, but yes, Amazon tends to distinguish AI as these higher level services that are sort of API calls. They're actually labeled. They're all labeled machine learning. In some of the in most of the reInvent and sort of recent documentation and slides, I see almost all of these are under AI, and then SageMaker is sort of the machine learning. So said differently, you can build your own models and train your own models and have complete flexibility with SageMaker, but this is also lower level. What you may want to do if you're starting off is give some of these services a try. So there's Comprehend, which is sort of doing natural language recognition, which is doing video and sort of image classification. Poly, which is doing, I believe this is text to speech, and there's also speech to text, I think transcribe. So all of these are higher level APIs. And actually, I've been using Personalize quite a bit recently, and this is super slick. So instead of doing your own factorization machines within SageMaker, for example, like was one of the examples I was showing before, you could just switch and just try Personalize. So instead of building your own sort of recommendation models, you can actually reuse Personalize, which has been trained on. And so you train it with your data. You actually just think about your data, point Personalize to your data, and then out comes a model that's actually fairly usable. So by this day and age, collaborative filtering and generating recommendations is so commonplace, and we've done it 5,000 times. And there's so many different models that pretty much all do the same thing, maybe small little tweaks specific to a particular domain, to video domain, or to Instagram domain, or Pinterest domain. But you could really go a super long way by just using Personalize and just pointing it to your data, and then getting back item to item similarity, getting back user to item similarity, and start servicing these recommendations and not have to deal with Docker images and SageMaker APIs and things like that. But if you're like me, you like to get in beneath the covers and see what's going on and dive deep here. So let's dive deep and show SageMaker. This left navigation is just getting bigger and bigger every single time I look at it. So SageMaker, there's data labeling here, which is called ground truth. You could set up sort of private workforces to start to label images. And you could also do something called augmented AI, just kind of skipping down here, which is essentially ground truth, but you're setting up a workflow that then you can label misclassified predictions, and they go back into this workflow and then become part of the next labeling job. Become part of the next training job. So ground truth is a whole topic on its own. That's, there's startups out there doing this. Yeah, so check all that stuff out. And then there's notebooks here. So this is really what the sort of entry point for most of us is. So I click on this, I can go in, you can open Jupyter, supports JupyterLab as well too. I'm I'm going to do Jupyter here because there's some visualizations that I potentially want to show. And here's all those. These are all of the those repos from data science on AWS that I have created. Some of these actually are pretty slim, even empty. It's because we haven't gotten a chance yet to copy from our staging area into this. But one thing I'll show is the SageMaker processing job. So this is what I'm going to demo. I'm going to do the Spark one. I think I'm just going to do Scikit, or at least talk to it. But let me continue on here for a sec. So let me see, where are the processing jobs? So processing jobs, actually, they're so new that they're not even in the left UI yet, the left nav. So they came out at reInvent. They like really build upon right, like the other base primitives of Amazon, batch and of course IAM roles and all the goodies that so Amazon Web Services gives you. But they will show up here soon. We'll be showing the API that invokes them and then how to actually look at the running jobs, that, even though we can't see them here in the UI. We actually figured that out, I think, yesterday, the day before, that they're not even here in the UI, but we're still able to use them. So the idea of a processing job is to do pre-processing, right? So any pipeline that you have, the second that your data, your raw data comes in and it's not ready to be passed into a machine learning model, you have to do some type of transformation or some type of processing. Note that batch, there is something called batch transform jobs. As best as I could tell, and yes, maybe Ansha can correct me here in a bit, but batch transform jobs seem to be more on the prediction side, more on like inference, whereas pre-processing will probably end up as it's, or the like processing jobs will likely end up inside of their own little drop down as, feature engineering, something like that. Not quite sure where they plan that. These are the algorithms. So these are built-in algorithms, I believe, or you could create your own algorithms, and you could either, I can create my own algorithm and import the script and do all that, or I could actually purchase somebody else's or borrow somebody else's, and I could search the algorithm marketplace. So this is something that like Amazon has been famous for even back in the Amazon.com days when they opened up Amazon.com marketplace, which seemed counterintuitive because why would Amazon open up their platform for others to sell? But the idea here, this is one of the core Amazon.com tenets, the whole company actually, is let's offer more services, offer more choices, and that will then lower prices and create a fun experience for the users. So same thing happens here. We could search this and actually rent sort of other people's algorithms. Or you could even create your own and then sell it on the marketplace, which is kind of fun to think about. Okay, these are the list of training jobs. Note that when you call, if you did call from KubeFlow and said create training job, it would actually create the training job here. And you can go into the console, you could see it. You can go into like CloudWatch, see the billable time. So this is 59 seconds. See which Docker image was used, look at any metrics that came out. Here's all the metrics that came out. That's the regex that was used to generate it. And here's the hyperparameters that we used. So we're starting to see the experiment tracking, right? So we'll probably talk more about that next month. And we'll definitely talk about it on Saturdays for the workshop, but stay tuned for that. Here's hyperparameter tuning jobs. This is classic hyperparameter tuning. So here we should see the different runs. This also highlights the best training job based on what you were trying to optimize. I'm not quite sure what happened there. But yeah, this is where you'd see hyperparameter. There's also AutoML now. It's called Autopilot. That was released during reInvent. Not quite sure where that shows up in the UI. But okay, and then there's like the inference. So when we actually do deploy the model, we will push it to an endpoint, and these are actually live endpoints. I should probably shut these down. They've been running for a while. I haven't really been using them, but you would call into these. So these were the result of calling from my notebook when I called .deploy. It takes a few minutes because it's pulling down the Docker image, it's spinning up the instance, and You can also now deploy multiple endpoints per physical instance. So if you do have hundreds of different models that you're trying, you could actually run them on the same physical instance and have some cost efficiency there. So batch transform jobs, again, this right now is under inference. So this is more you, instead of creating an endpoint like a REST endpoint, you would point the model to an S3 bucket, and then it would do batch transformations and then write it back out. Okay, so I think covered everything there. The batch processing, the processing jobs, which are feature engineering, don't show up here, but let me go back to this. So here's the notebook. This is I glaringly large here, but yeah, here's the idea. So think of it, it's pretty generic, right? And that's on purpose. Processing containers, there's going to be inputs, there's going to be outputs, there's a standard way to specify these inputs, outputs. These get mapped inside of the container to a well-known directory that you could reference from your code. So inside the container, your data will live at opt_ml processing input. Your code will live at opt_ml processing code. The output will be opt_ml processing output. And this is where you would specify the S3 bucket for the input data. You give it some sort of output bucket, probably an empty bucket, hopefully, and then that new data will get the processing. So no matter what you're doing. Now, typically, we're not training models here. So typically, and we're also not doing batch predictions here. This is simply to transform the data. So let's say I take the Amazon reviews data set and I want to strip out all reviews that have less than 20 characters because they just say great or good or high or something like that. So what we want to do is strip all those out. That's where this processing job comes into play. So the GitHub for this is, one sec, let me find the GitHub repo. Processing jobs. Spark, I'll put the link in the thing here. The way that we're triggering this is currently through a Lambda function. And that's just because most people are familiar with Lambda functions. We're actually going through the process of converting everything over to use step functions. But for now, let's just look at the notebook here. Okay, so here I'm just setting up the input bucket like I showed up there, pulling in some data just to kind of look at it, make sure everything's good. Uploading it. Here, we're just going to use the lawn and garden reviews. It's about 500 meg, but so it's still pretty sizable, but not the full data set. Here, so this is actually the more complicated one, and I'm starting with this because I come from Databricks, so I know quite a bit about Spark. So I wanted to tackle this and make sure that we could actually use Spark to do our feature engineering. This is very, very common. People have Spark-based pipelines already in place, and I want to show that you could do this still with SageMaker. Okay, so the trick here is we actually have to use a custom Docker container. Now, this Docker image already exists, and it's under samples. But just know that we're going to reuse this. And this has Spark 244, the latest Spark, but there's still a tiny bit of Docker image stuff. When we show Ansha's version, which is just Scikit, you can use just the SageMaker API. But Spark, which has always been a little bit wonky when it comes to Amazon Web Services, it is still requires a little bit of shim. But this framework is flexible enough where you can use your own Docker images. We've already provided Docker images for you to use. All you have to provide is your Spark script. So think of this like script mode for SageMaker processing jobs. So this should look familiar. If you're a PySpark person, you'll know Spark session, get or create, giving it a name, setting up some Hadoop configuration stuff, Here we're actually defining the schema right in line, so you see exactly what it is. We're then reading. This is actually a TSV, that's just the native format. There's also Parquet. When I was debugging this, I wanted readability, and this was a small enough file that I just used TSV here. You'll notice at the very bottom, I actually have to do Parquet, so that's coming. But read TSV, here we're filtering and saying only preserve the reviews with a body size greater than 20 characters. It's just a pre-processing thing that we're trying out. Maybe this will make the overall model better, maybe it won't. Doing our Spark select, group by. Here I'm actually doing a count. So I'm actually doing multiple side effects from this particular processing job. I'm summarizing the data and putting it under category counts. I'm also averaging per category the ratings. And yeah, I probably could make this a separate job, but just to keep the code simple, I put them all here in the same job here. And now this is really where we would be doing, more feature engineering stuff here, would be filtering. And then if we just kind of ignore this sort of aggregations, and then we're splitting in training. So doing 80% training data, 20% for validation, and then writing each of those data frames to their own subdirectory within the output. So somewhere there's an S3 bucket that I've passed in, and all of this gets wired up here. There's something called script processor. I'm giving it a name. This is boilerplate that's specific to the Spark processing. This does not have to be done for the regular Scikit one, for the more native. Of course, giving it a role. Hopefully this role has access to those S3 buckets. And here we're actually giving it an R instance. So R is RAM. So this is high RAM, very common in Spark workloads, R5XL. And give it the max runtime. So therefore, after 5 minutes, if this thing has not completed, then something's wrong and kill it. Environment Python mode, this is, again, specific to the Spark implementation. So again, I'm showing you guys the most difficult one, but to me was the most important to get running, because if we can't do SageMaker processing with Spark, then it's not as useful, in like my personal opinion, just because of my experience. So I got some errors there because I was doing stuff right before this, but just know that you'll see you can actually run this. So this is the alternative to the UI console. So this is what is not currently in the UI, but list processing jobs, and this will show, here's a particular job I was running there. Here we're getting the output, displaying the output, showing, and then we could go on and then train a model. So again, this is using the notebook to sort of spawn these jobs and wait for them to finish, and then go on to training, spawn the training job. There should be an estimator, yep, right here. If you're using TensorFlow, you would use TensorFlow. PyTorch is actually appears to be using a custom image here. I believe this is XGBoost, and then calling fit at some point right here. So there's fit. So this is actually doing a pipeline within the notebook. So again, we're converting these over to use step functions, and you'll see those popping up in the step function pipelines here, which looks like there's a couple sample ones, but we'll be polishing these here in a bit. Okay, crap, I didn't realize we only have 10 minutes. Let me hand this over to Antje. Antje, go as long as you need.
Yes, if you just stop your share. Yep, so I do redo. All right, so you just saw the processing jobs example with Spark. So what I'm going to show you is a little bit the lighter version with the Scikit-Learn. So again, processing jobs, Chris has explained for the pre-processing. In this use case here, we use the census data set. So that's basically just a collection of census information from the US. And we'll see a sample of the data set here just in a bit. We start again with importing a couple of libraries. So Bodo3 is the Amazon Web Services Python SDK to have access to the Amazon, the AWS services from the notebook here. We import the SageMaker Python SDK. And then what you see here is that we're using a pre-built container, a Scikit-Learn processing job container. And this we're doing here with SageMaker, Scikit-Learn processing, import sklearn processor. We're pulling in a little bit of information, our execution role here for SageMaker, the IAM role. And then we're also doing a little bit of configuration here right away. So we're saying for this Scikit-Learn processor, we're passing the instance type again, which one we want to use, instance count, etc., the framework version we want to use, etc. All right, so have a look at the data set here. So as I said, it's census information, so it's about US citizens here. So you see categories of class of worker, educations, wage, and what we want to do here in this example is basically do a classification whether the person has an income over 50K or less than 50K in a year. All right, so again, we're doing some pre-processing. That's the whole idea here. Here's a script. So we're basically doing here, again, a couple of imports, getting Scikit-Learn, and then we're putting in the columns we want to use, also the labels of the class here, as I said, like below 50K a year, more than 50K a year. And then starting here, reading the input data again, putting it in data frames, making sure we drop any duplicates. Also, we're doing a little bit of transformation here with the numerical columns and transforming those into categorical features. So it's all described here above. You can read through that. So we're basically doing the transformation in the script. We're writing out the script so we can use it. And then what we do here, once we have that pre-processing script, we're calling the Scikit-Learn processor run command. And we're specifying here as input the Python code we just wrote above, and then passing here again where to find the input data, which again resides somewhere on our S3. We're putting it to the local container destination folder here, which is also like the opt.ml processing input. And we're doing the same here for the output. So we're specifying where the output goes for the split data set. So we're doing the same split here, as you can see in the arguments, 80%, 20% between train and test. And we're also telling it where to save that information. So it's going to be a train folder and a test folder. And then basically we're kicking off the job that again gets translated to this processing job and does the execution. And also then it saves out all of that information to S3. And if I go here quickly on the console and check out my S3 on the right, it creates folders, and basically it's some custom naming. You can also change that, but basically it creates those folders. Here's input code where it writes the pre-processing file into, and then there's another processing job when it actually kicks off the script. And then you see here, for example, output, where it, for example, saves the model later, and source information. So it also like pushes out that information to S3, and you have access to it to kind of, do some processing afterwards. All right, back to our main script here. So the processing job runs in the background. You can also see here in the log the exact folder where it pulls the CSV data from, and then basically the local folders, and also here the output. So if you want to see like those folders in S3, it's exactly mentioned here in the logs. And then once it's finished, we can actually have a look at it. So we're pulling the pre-processed training data, having a look, and here you can see that the data has been transformed. So this is the training features now. And then you can actually kick off the training job. So here again, we're calling Scikit-Learn and giving it an entry point. In this case, we're providing a training script, also the instance type. And here, for example, we're putting together a training Python file with pretty much known content, I guess. So it's not very difficult. You're putting, pointing it to the training folder here again in the container, passing the training features and the labels. And then you're basically also dumping out the model. That's what we just saw in S3 already. I ran the jobs before it, so we have the output and don't have to wait. And then basically you're doing the Scikit-Learn fit and pointing it to that preprocessed training data and kick off the job. So again, this is being executed in the background. In this case, you actually see the training job in SageMaker because this is executed as a training job here now. And just scroll down. What you can also do is then do some model evaluation. So in this case here, we put together an evaluation Python file, again, pointing to the local folders here in the container image, and doing here, loading the test features and labels, which we split in the first task, and then basically executing here and reporting, for example, on accuracy metrics. And if I run that then also as a processing job and do the describe, and then I read the file, so we see here the outcome. I just do a quick fast forward here. So with that, we kind of see the output, like for example, they have 1 score, precision recall, etc., and we can evaluate our model this way. So this was a quick run through the Scikit-Learn example. Again, also here, you can obviously run your customized Docker files and Dockers if you have your own dependencies. So basically putting together your Docker file, in this case, just an easy example, like put in like third and pandas and Scikit versions. And then you can basically also use that Docker container. You build it, you push it, and then you can do the script processor run command, and you're pointing it to your image URI you just built, and then also you're just calling the job exactly the way we did before, but this time basically it executes with your custom container that you built. So this was really kind of the very easy Scikit-Learn example for processing jobs. And Chris already shared the GitHub link here where you can find the GitHub code. So if you want to give it a run for yourself, feel free. It's really fun to play around with, and yeah, great way to get started with those processing jobs, to do the data pre and post processing, and also model evaluation with those new SageMaker processing jobs. And with that, I'll hand over back to Chris to wrap it up.
Okay, thanks, Antje. Good stuff. I actually learned a couple things on that. One thing I didn't realize that you made me realize, so cool. Okay, and wrapping up, I actually have a surprise for everyone who stayed on the line. I'm going to post this link into the chat here. If you could rate this event, you'll get $25 AWS credit. So I think it's just 2 questions. It's rate us as speakers and rate the content that we provided. So this particular, so just to kind of remind everyone, this particular event is really monthly updates on what we're working on and sharing with you kind of the latest and greatest. And literally, we got these things working, or I got it sort of working just minutes before, just to kind of summarize everything for you guys. So this is always kind of a moving target. We always mold this clay and put things into the Saturday workshop. We'll, like once again, ask you guys to rate the Saturday one. But thanks a lot for taking your time. I know it's an hour and it's a Monday, but hopefully you found this valuable. So grab that link, and if please ask any questions. I'll open it up here in a couple minutes. Looks like we had a couple questions about personalized. Antje took care of those. There's a few different algorithms. Okay, and please ask the question to all panelists and attendees. One sec here, my laptop went to sleep. Okay, 1 second. Okay, someone's asking about Databricks versus AWS. I would rather not comment on that, but I will say that Databricks is a great company, and there's lots of space. There's lots of room for competition. Databricks has done a really good job making Spark super usable, And, in my opinion, I think things could be a little bit easier on the AWS side, right? Like again, AWS really focuses on building blocks, and we're just now starting to see, more higher level services coming through in these AI services. I'm particularly paying really close attention to the Spark support within SageMaker, which is why I was very excited to get the Spark example working. So Spark on like AWS is getting easier, and in my mind, it's flowing through SageMaker. The other benefit of having this stuff flow through SageMaker is that customers, when like super large customers, when they need to whitelist specific services or like evaluate these services sort of each on their own, and it takes a little while to actually get the whitelisting and get the approval. When these things flow under SageMaker, they know that yes, everything follows the same SageMaker security and the same SageMaker pattern. So yeah, there's quite a lot of people using Databricks. There's also quite a lot of people that use EMR and Glue with Spark, and yeah, plenty of room for competition in that area. Is there a notebook that uses KubeFlow and TensorFlow on AWS? I had an operator notebook. Yeah, but I don't have it offhand. But if, but yeah, I thought I did. I'm trying to remember where it is. It's somewhere. The question is there a notebook that shows the KubeFlow and the operator, or let's see, KubeFlow and TensorFlow on EKS? Do you know what you can do? There's actually an EKS workshop. There's a github.com/AWS/ There's something called EKS workshop, which is pretty slick. And here's the link there for EKS workshop. You could probably find something in there. I think that's where I got it from. This is actually a full workshop end to end. Pretty cool stuff. Here's the full link there. This is actually, some of this content is what we'll be doing on Saturday for the free workshop. We'll specifically be focused on the advanced section and machine learning with KubeFlow. So that's specifically the area. And I believe there's a Jupyter notebook in there. I can't remember if it uses TensorFlow or not, but that's like great feedback, and I'll try to work on that one for next month. Let's see, okay, Airflow and Spark. I don't know of one that uses Airflow and Spark. I know of one. So I've been focused on these processing jobs, which I've got that working with Spark. Let's see. I don't know of one that uses Airflow and Spark. I'll take that as a note for future SageMaker workflow. Okay, yeah, Ancha found a good link here for using SageMaker with Airflow. Any comments, Evangelos, this on production ML tools in general? KubeFlow on GCP, Azure, AWS. I work for AWS, so I'm going to say use KubeFlow on AWS. In fact, one of the big reasons I joined like AWS recently was they are paying attention to KubeFlow, and I was a little worried about that. Probably last year I might not have thought that, but then I caught wind of EKS workshop and went to KubeCon and started seeing more and more Amazon people speaking at KubeCon, and met with those people and sort of discussed what's going on. And my particular role is straddling both SageMaker and KubeFlow. Haven't quite gotten to where I want to yet with the assets. That'll be coming on Saturday with the actual content. But this EKS workshop is pretty darn close to where I want to be. And so I'm building off of that. So yeah, obviously KubeFlow started off as a Google project, but they are very, very open. I call into all those meetings all the time to make sure that there is nothing going on that's specific to Google. They're very conscious of that, and I could say from the AWS side, there's actually quite a lot more support for KubeFlow internally than I thought there was, and learned about even more after I joined. So yeah, KubeFlow AWS, very good combination, and that EKS workshop actually shows you how to set it up in a nice, clean way that supports all the IAM roles and even the open ID spec as well too. Yeah, good questions. I've actually never used KubeFlow on Azure. I will say one of the creators of KubeFlow, this is public knowledge, went to Azure. And so, you know, sort of by default, you can imagine that like Azure will start to show more and more support for KubeFlow natively. But yeah, my personal favorite is AWS plus KubeFlow. And this weekend we'll be doing AWS plus KubeFlow. And if I don't see you on Saturday, hopefully we'll see you in a future Saturday in the coming months. So thank you much. Yeah, Anshu, you still there?
I'm still here. Thank you everyone for joining today.
All right. I'll post this video to YouTube. It was a pipeline, HTTPS, youtube.pipeline.ai. And we'll see you all soon. Thanks.